So how to hook up the compass to the ESP. So here's it already hooked up. I use an ICM 20948. It's a very good and wide available compass. The chip itself, it's super tiny. So this is the chip itself. It has an accelerometer, a gyroscope and a magnetometer. Magnetometer senses the magnetic field. Both three sensors sense it in three directions, so the X, Y and Z plane. On the back you will see an indication how it's oriented. It doesn't matter how you oriented the compass. Upon startup of the ESP, it detects the orientations and the side that is most up is regarded as the up side. The placement of the compass is should be as far away from high current running cables. So in our case that will definitely be the wires from the motor, and permanent magnets like speakers or metal. It does compensate for metal and permanent magnetic field distortions, come to it later. So it uses the ICM itself, it operates on 1.8 volts while our ESP is 3.3 volts. So what P. Moroni did is adding a voltage converter from 3.3 volts to the 1.48. Also the logic level, it's I square C. It operates on 1.8 volts, so you need a logic level shifter. These modules are roughly $20, 20 euros. So I very much prefer to use the breakout board. So what we would do is I quickly disconnect it to give a full tutorial. It's advisable to power off the wires. So let's first go to the beep. What you hear is the loss of connection. So I have the P. Moroni here. It is the purple wire is the voltage. So let's hook up the purple. So this breakout board has a separate part for the ITC pins, which is very convenient. That's why I like to use it. So the purple is there. Then the ground pin in my case is the yellow wire. So let's hook up the ground pin. So now blue is SDA and SDA is pin number 21. So let's connect it to pin 21, and then SCL in my case is green. Just double check is SCL's pin 23. So now it's hooked up. So it didn't find the compass yet. So so now the compass is here. Let the app connect. It's connected, the blue light turns on. So once you're in the app, what you can do is set the source to Autopilot compass. And immediately, if I would turn my compass, it isn't the best camera. If I turn the compass, you will see where it's pointed to. So what is very important, it works straight away, of course, is if you go to the settings, you go to the sensors, then first you always calibrate the magnetometers. So make sure it's still, it should not move. So calibrate gyroscopes, hold your boat still for 2 seconds. Okay, its calibration is done. Now calibrating the compass. And then you have to wave it in a figure of 8. The idea is that each axis gets every possible orientation. So imagine you're standing in a sphere and pointing your finger towards each point of a sphere. So it starts now, will start, it says, and then you just move it gently, roll it over, turn it around, and if it is enough points for calibration, it will show you the settings. So it found a magnetic field of 45 microteslas. The compass scale is all 1.0, which means there's no magnetic interference. The bias is, for example, relatively small numbers. It means offsets for metal nearby, and actually the main metal nearby are these little capacitors on the chip itself. So it's compensating for that. And now, of course, you see that if you rotate it, you see it rotating. And of course it works if you now turn it on. Oh, let's turn it off. Oh, my hand is shaking. Oh, it's difficult. Oh yes, I get it still. And now it's correcting, you see. Whoa, this is so difficult. So now I got it sort of under control.